All right, so let's do something a little bit different. We're just gonna dive into some debugging to look at this latest RodrigoStealer. I don't know, it's all blurring, but yeah. So let's get started. I talked a little bit about this already, but it's good to recap. So what this is doing is this is the main OSA script command that we see in these stealers. It's huge. And essentially, there's a function that dehexes this string because it's stored in the binary as hex values for ASCII strings. So the actual ASCII hex values are stored in the binary, and that is converted over to a string in C++, and then that's converted to a C string, which then is passed into the system function. Okay, so let's just start our session and we'll walk through it. Okay, so B main, run it. We're at the start of main, and we're going to branch or set a breakpoint here. So B 0x1000043 Okay, so we're in the right spot because we see this gigantic blob here of hex values. And we know that that's being loaded into x0 or x1 in this case, and then a buffer is being loaded into x0. How do we know that? Because SP is pointing to the stack. SP always has an address, and when you add to SP, it's like an offset to an address on the stack, and you save that into a register, so you move a pointer to the stack onto a register, and that can be used in like for a buffer to return a value into that location, which is what's going to happen here. Okay, so let's press next. Next, that is moving that stack pointer or this pointer to the stack to this register. So let's just copy this so that we can see how it changes once this actually runs. We can take a look at it, and you can see it's just zeroed out. Okay, so now we are at the call to this basic string allocator, which is going to create this string, this C++ string. Okay, so next, if we look at the contents of that, we see that now we have a pointer. How do we know it's a pointer? Just see it a bunch of times and you recognize that it's a pointer, but it's backwards because this is stored in memory in Little Endian. So we just need to kind of reverse it in our heads here and make sure I can do this while talking. Oh. Okay. So X for memory read, and we're looking at the return from that string that was created. You can look at it here. So that's what we should expect. Okay, cool. So the next thing that happens after that is this call to signal, and we're going to skip over signal, and we're going to skip over fork. So fork specifically is used to prevent you from debugging this, since it forks out and then it checks the return value of fork, and we're just going to skip that mess so that we can continue debugging. So set a breakpoint at 0x100004384. Oh, I'm missing a 0. Okay, so continue. We're at the call to signal. It's a little hard to see, but there it is. Signal. We're going to skip over that just to prevent complications. So the way we do that, reg write. So we're going to write to a register. We're going to write to the program counter. which is currently pointing to this address, and we're going to make it point to the next address. So we skip over that branch and link. All right, skipped. Now we're going to do the same thing, and we're going to create a breakpoint at fork. This is more so to show how this works, because it's good to know. C4, continue. We're now at the call to fork. And we're going to skip this fork. And we're just going to skip all this stuff. This is the check for the return value fork. And we're not worried about that. Let's just go right here. So, reg write program counter, and we're going to pass in the address 100043D8. Awesome. Okay, so in C++, just to talk about this a little bit, you can use the X8 register as an indirect return, which is how this is going to be used here. So again, when you add to the stack pointer, you are calculating like an offset of where the stack pointer is pointing to, and you're moving that address pointer to that location as a buffer into a register. So that's what's happening here. And then this is recognizable. This is what we saw before, that those strings that were turned into, those bytes that were turned into a C++ string are then moved here, and then it's going to be passed into this hex decoding function. They actually called it hex decode, so that helps us know how this works. Okay, cool. So next, and before we go, let's just make a note of these addresses. This is the indirect return pointer. So let's just keep an eye on that, and we're gonna click next. Okay, so we're bypassing this hex decode because I don't want to spend time on that. If we look at it really quickly from a high level perspective here, we can see that it uses string streams. It gets the length of this hex string, and then it creates substrings for that, and then it uses this operator alongside this, I don't know how to say it, STOUL function call, which goes through each two of those bytes and then converts that and returns that result. Okay. So we're not going to focus on that too much. Let's go back. Move this over. Go back. We should now have that dehexed return value stored at the indirect address that was passed in via the X8 register. So let's take a look at that. So this is an address that's stored, right? A pointer that's stored at this location. So we just need to reverse this to see its contents. I know it's a string because looked at this before, and that's what we should expect to be returned. I think that's right. Yes. So here goes our command. Awesome. But in order to pass this to the system function to actually run this, it needs to be converted into a C string. So that's what happens next. All right. So that is then going to be passed into this C string function. So next, read star 0. That's that same address that has that pointer. And we then pass this. Let's get a copy of this. We're going to pass this over to system, but we're not going to actually run that. We can see that address, which is that string, which now has been converted into a C string. 1258113C0. And that's then passed into system. So that's how that part of this binary works, to change those hex bytes into a C string and run it using the system function call. Cool.